Hey, ninth graders. So we are continuing our exploration of functions and their graphs. So the main takeaway from our last lesson was to talk about can you grab points from graphs? Can you to talk about like domain and range? And today we're going to enter in a few more things that we look at with graphs and their functions. And we're talking a little bit more about some more mathy terminology. And so we're going to talk about intervals that are decreasing, increasing, or constant. And then we're also going to talk about something that's called a relative local maxima or minima. Okay, so a lot of times we care about, and it goes all the way up to calculus, we care about when a function is increasing, when a function is decreasing, but most importantly, when the function is constant, and intervals in which it's doing that. We always read from left to right. Oops, to right. Graphs. So if we're talking about a graph that's increasing, we're reading from left to right. Is it going up? It makes it increasing. If it's decreasing, reading from left to right, is it going down? Okay, so we read graphs like we read the English language, which is from left to right. We also have a very mathy way of putting this if you want to talk about a definition. The definition of increasing, a function is increasing on an interval. We use the shorthand IFF, and it just means if and only if. I know it's like a really weird phrase, but the phrase means that it's a two-way street. So it means that if this first part, then the second part. The if and only if part also means if the second part, then the third part. A common way that we talk about this is sidewalks being wet. If a sidewalk is wet, then it is raining is not always true. It could be wet because somebody spilled a glass of water. It could be wet because the sprinkler systems are on. But the flip of that, if it is raining, then the sidewalk is wet, is true. And so that's an example of not a two-way street where it works one way, but it doesn't work the other way in terms of rational statements or logical statements. So an if and only statement says that it works both ways. If this first part, then the second part. Also, if the second part, then the first part, if and only. A function is increasing on an interval if and only if for every x sub 2 that is greater than x sub 1, that then also f of x sub 2 is greater than f of x sub 1. If we think about 2 points, x1, y1, x2, y2, if we're talking about a graph that's happening, it is increasing if when x2 is greater than x1, in other words, when we're talking about from left to right, then the y value of x2 is greater than the y value of x1. We've gone up from the previous point, okay? Versus a function that is decreasing, a function is decreasing on an interval if and only if for every x2 greater than x1. So again, we're talking about, hey, we're reading from left to right here. x2 is greater than x1 means that we've moved from one x value to the next. Then f of x sub 2 is smaller than f of x sub 1. Like moving from left to right, x sub 2 is greater than x sub 1, then the y value of the second point, let me get it in the screen, is below. The y value is below the second point. For constant, a function is constant on an interval if and only if for every x2 greater than x1, f of x sub 2 is equal to f of x sub 1. So, okay, we're reading from left to right. We're talking about something being constant. Their y values are equal. That's all it means. Fancy math way of saying, hey, your y values go up or they go down or they remain the same as long as you're always reading from left to right. That's all that's saying. All right, your local minima and your local maxima. So when we're talking about a parabola, your vertex is a local, could be minima or could be maxima. But as you can see in this graph below, we don't always have a function that looks like just one hill or just one valley. Sometimes there's multiple. When we're talking about a relative maxima or relative minima, we're talking about any of the points that might be a maximum if you were just focusing on that interval. So notice that this is the maxima for the whole graph, whereas we have two minima. This would be a minima and this would be a minima. It's the idea of a changing behavior. So you have a relative maxima and a minima if you have on either side of that point a change in behavior. Maybe on one side it's going on up and the other, maybe on one side it's decreasing and on the other side it's increasing, right? And then there's that shift of decrease to increase versus this guy, there's an increase shift to a decrease. So that's how you know whether something's a relative maxima or minima. The minima here, right, if you're talking about the ultimate max or the ultimate minimum here, we're talking about this point down here. But if we're talking about the fact that there could be multiple of them, we're talking about both of them right here. That was not my best explanation, but we'll continue to practice it. I'm so sorry. Okay, let's talk about the math definition. A point, and we're going to call this point fx and then f of x, f of x, is a relative maximum if and only if, so it's a two-way street, the function is decreasing on the right and increasing on the left of x and f of x. Okay, so what that means is, hey, this is a relative maxima. Your relative maxima, if you look to the right, should be decreasing. It's an interval in which we're decreasing, versus to the left, we're talking about an interval that's increasing. So it's just kind of this idea of having an interval that reading from left to right, it's increasing. The definition of a relative minimum is the opposite. A point, x and f of x, is a relative minimum if and only if the function is increasing on the right and decreasing on the left. And that's it. Those are all of your definitions. Those are the things that we're going to talk about in the graph. So last time we were talking about, hey, can you pull values from a graph? Hey, can you talk about domain and range? And now we're going to say, hey, can you talk about intervals on a graph? Hey, can you talk about maxima and minima on a graph? So we're just kind of stepping it up a little bit. Okay, so we're going to use the graph on the right to practice these things. The graph of f of x is shown to the right. Where is the function increasing? And so how I like to break up these functions is I like to create little like fences using my little dotted lines, and I like to put them at maxima and at minima, because at the maxima and at the minima is when behaviors are changing. So if I'm talking about a section where it's increasing, I want to break it up into sections that are strictly decreasing and sections that are strictly increasing. And where those divisions happen will always be at the relative maxima and minima. Now that I've split it up into sections, I have 1, 2, 3, 4 sections. I'm looking from left to right, where are we increasing? And that's in this section, we're increasing. And in this section, which only happens to cover a distance of 1. So those are our two intervals that are increasing. And we now need to talk about how we talk about them. So we have two different types of brackets. We have what we call soft brackets and we have hard brackets. They're like your open and closed dot. Your soft brackets are also what we call parentheses. Soft bracket or parentheses. They do not include the value that we're talking about. So if I put a parenthesis around the number 4, I am not including 4. I'm saying everything up to 4 is this. So for instance, between this value and this value, we are increasing. And intervals always use x values. So between -1 and 1, we are increasing. So I would say, okay, -1 to 1, we are increasing. That's a range of values. And how we finish up the idea of a range of values is we put brackets on the end. And we always have to think about, okay, are we including this value or are we not including this value? For this guy, where we're increasing, starting at -1 is a relative minima, which means it's neither increasing nor is it decreasing. It is constant at that one point. So we don't include -1 because we're not increasing at -1. Same with at +1. We're at another relative maxima or minima, so we're neither increasing nor decreasing. We are constant at that one point. So we don't include it. So for right now, if that didn't make sense, all I want you to think about is when we're talking about intervals, we talk about x values. So between the x values, -1 and 1. And then we put brackets on the end. And right now we're not including them. We'll continue to talk about it. Notice that when we talk about intervals and we put soft brackets on either side, they look like a point. Be very aware of that. It is not a point. It is an interval of values. Okay? So you need to know how you know whether it's an interval or whether it's a point is the context of the question. Where is the function increasing? You would not be giving a point back for that. You would be giving a range of values. So where is the function decreasing? The function is decreasing. Oh, and I didn't even finish answering the question. It is also increasing between 4 and 5. We also do not include 4 or 5. 4 because it's a relative minima, and 5 is because it's the end, so it has no behavior because there's no point after the end. It is the union of these guys, so I drew a really, really tiny U. We'll learn more about union this year, but that just means that we're including these guys. It's like a bowl. Think of it like a big bowl. We're putting all these values into that. Where is the function decreasing? There are also two sections where the function is decreasing. Sorry, this pencil is, I'm on the struggle bus today, guys. Sorry. So the function is decreasing between these 2 points. This is an x value of -1 and an x value of -3. So between those two x values, we are decreasing. I don't include them. -3 to -1. It's always the smaller number on the left to the larger number on the right. Union with the other interval, which is between here and here, which is decreasing. That's an x value of 1. Here's -1. Here's -3 to 4. Oops. There you go. So decreasing between 1 and 4.